Okay, so we're going to take a Python Flask image and we're going to deploy it onto the K3s server. In order to do this, I needed a shell of a project that has Python Flask project with a Docker file already built in. I am using the one that is available at this URL. You can go and see. And all you have to do is then just do a git clone of this repository using git clone, and then you type in the name of this, and then you put the name of this repository, and you'll press enter, and you'll get the project. Since I've already done that, I won't do that again. But you can see that once you do this step, you'll see this folder created called Python Flask Docker. Okay, so we've done that, and then so I've already done that. So I have the copy of the project available to me, and I'm going to briefly show you what this project is. It has a Docker file and has the application, which is essentially a so we're going to modify this, and here is the Flask application. Very simple, very nicely done, and essentially just gives you a render template, which is a way to generate an HTML index page with the address typed on it. I'm going to show you what the address in the template they've provided in this repository is. The host name of the container is this host name, and its IP address is this. So when we run this server, you're going to see this HTML on the browser page. Okay. So in order to do this, I had to do a few things that I want to talk about. And you may or may not have to do all of these, but I'm going to show you the script that I've built for this. So oops. So I need to go back, and I need to show you the build script. Okay, so the build script is doing a few things. Okay, actually, let me clear the screen and let me cat the script. So the script actually is asking for name of the application image, right? So what do we want to call it? Are we calling it a I'm in my case, I'm calling it a Flask hello. You can call it whatever you want. You can call it cart service, or you can call it app backend service, whatever you want to call it, right? Some name of the image, right? And then you provide a tag if you want to version your Docker image. Your tag will go there. Now notice that I am providing a default value. If you don't give me something, I'll use the latest as the tag. So that's just a nice little helper thing. The bash allows you to default the value of a variable if you don't have one already, provided on the command line. Now the third line is essentially grabbing the IP address of this K3s, the VM that's running the K3s, right? It's just grabbing the IP address. If someone has a better idea on how to grab that, please let me know. This is my poor man's way of doing it. So I'm just asking for what is the IP address of the ETH0 interface, network interface. Once I get the output of that command, then I'm saying, hey, I just want to see the inet interface. And this is where you can sort of see what all the virtual interfaces Kubernetes creates, right? So if I say if config and I ask for a small list, you can see all of these virtual Ethernet interfaces that have been created, as well as the CNI interface. All of this is container networking, right? But I'm interested in the real VM level non vETH version, ETH0, right? So in my script, I'm asking it to give me that. Once I have the inet section, right? So let me just kind of do this real quick in front of you. So I'm basically doing this. Sorry, this. Okay. Okay, that was not what I was expecting. Oh, eth0. Okay, give me this, and then from there, once you have the eth0, give me the internet address portion of it, and then once the inet one is given to me, just trying to see. Oh, you know what? I think this is what I'm doing wrong. So first, give me this. Okay, this is what I meant to say. Give me information about the internet interface called eth0, and then we were asking it to give us the inet section of this thing, which now you see is getting closer to the IP address, and then you do remaining. The remaining part of the command is just doing this part of the command is cutting and printing out the IP address. So if you look at this entire command over here, essentially it's just saying give me the IP address of the VM that I'm running on, and then that nip.io is just so that I have a URL version. I don't have like a real domain name tied to my VM's IP address, so I just put like .nip.io. That's an easy way to turn an IP address into a URL. Then slash is the base name. The base name is essentially whatever you're calling your Docker image. If you're calling it my app, then that's what it would be. And then with colon, I'm calling the tag. So the tag would be like it could be something like 2.5 or whatever version you want to call it. Then we have an echo statement that says, hey, I'm building this image with this building for this image, and I'm going to push it to this repo URL. So we are just essentially just printing out a line so we can easily see it. Then we ask the podman, say, hey, podman, build us this image using the Docker file that you'll find in the current directory. Okay, so if you look over here, if I show you what I have right now, I have a Docker file that was already provided in the Git repository that we're using. And so once we use that, we tag it with the name of the IP address of the VM .nip.io / the app name : the version name. Okay, so it's the repo URL, right, / app name, whatever you want to call it. You provide this in the and then you provide this in the variable, the argument to the shell script, and then you give it like some sort of a a version number or a tag or something, right? So that's what we're doing in that part of the script. And then I have to like to say, hey, look for this stuff in the current directory. That's what the dot is for. You'll find this Docker file in everything in the current directory. That's what the dot is for. And then I have to provide a few levels of information just to make podman happy. I'm running on WSL, so just want to make sure that if I found that if I don't supply this values, it doesn't work. So I just supply that. Now this statement, let me make it a little smaller. So this statement over here is just building the image. This next step is I'm pushing the image to the repository. And once that's all done, then the image is available for us to go ahead and deploy onto the K3s server. So I'm going to show you a run of what that looks like. I'm going to clear the screen, and I'm going to say build.sh. Notice I'm in the project directory right now. Okay, so in here, I'm going to say build.sh, build.sh. I'm going to call it Flask Hello. Okay, and I'm going to say I'm building a 2.2 version. Okay, so the first thing, Flask Hello, is the argument that I'm supplying, which is the name of my image, and 2.2 is the version of my image. Okay, so the Flask Hello is the name of the image, and 2.2 is the tag of the image. Okay, and when I click enter, what it's going to do is it's going to build that Docker image using the Docker file in the current directory, and it's going to package all of that up, and it's going to tag it, and it's going to put it so that Podman knows about it, and then it's also going to push it to our repository, and that repository is being also run out of, because I'm running everything on my single laptop. So the repository and the Kubernetes server, everything is running all on the same environment for me. So the IP address is being used because I'm running this command from the VM where the Kubernetes where the K3s is deploying as well. So the registry and the worker node is running on the same VM right now because I have a single VM. Okay, so when I click enter, you'll see the script run. It's going to build the Python project using the requirements.txt that is supplied, and then it's going to tag it, push it, and it'll be available for us to use. Okay, so here it goes. Notice it's building that application. It's going a little quicker because I have already built and supplied it in the past before I started recording this. So if I show you now sudo podman images, you can see that I have a 2.2 version over here. Okay, and that's something that I've just built, and it's pointing to the Docker registry that is running on our Kubernetes cluster as well. So if I show you the ingress, the Docker registry is already running inside of a pod. That Docker registry pod is exposed via a service, and there is an ingress on top of that. Okay, so when I hit 192.168.236.60 on port 443, it basically takes that call and it calls the pod on the port 5000 that's sitting on the back. So if I were to describe it for you, or if I could just show you what that looks like. So cat ingress 2.yaml, is it this? Okay, so notice, and this I got from the web, and I don't know exactly which URL, but it's essentially, if you Google how to deploy Docker registry ingress, you can, this stuff will come up, and then you can just kind of see, you can see that so this ingress is using the Nginx ingress, right? And ignore the let's encrypt prod thing for now. Just look at the host. The host is the same IP address where we can expose an incoming call, which is the IP address of the VM. And we're saying that, hey, whenever somebody comes in and hits this IP address, this one, on this path, go ahead and send them over here in Docker registry service at this port. Okay, and there's a pod running listening on this port. Okay, on TCP port 5000. So a request comes in on 443 HTTPS, forwards it to a TCP on the back end. Docker registry is running. That's where the thing is deployed. So then we can start deploying it, all of that. So another thing that I want to show you now is on the worker node itself, which is also where we are right now. There is a tool called CRI control. Okay, and then this guy knows when a call comes in to deploy stuff, it goes ahead and fetches things so that they are available to be seen. They're available to be run, and you can see these are all the images that are pulled. I did a deployment for Flask Hello before recording this video, so you can see it over here. And I'm going to now deploy 2.2 or 2.3 was. What did we just build? Did we just build 2.2 or 2.3? We built 2.2. So we're going to go ahead and deploy 2.2 now. And you can see the ingress. This ingress over here is running and listening on port 443. Essentially just forwards all the incoming traffic, takes it, uses a secret that I've built in the TLS. Had to go through like a couple of steps to generate the key and all that. And then once that's done, you can bake in a TLS secret. This call is happening on 443. It fetches it answers the call on port 443 and calls the pod on the backend on port on port 5000. Okay, so now we are going to make a deployment. And actually, you know what? Before we make a deployment, let's go ahead and look at the process. I captured all the process that I used inside of this thing called create cert. Okay, so if I'm going to say cat create cert, okay. Can I do pigmentize? Pigmentize? I don't know. This stuff is not working for me. Anyway, so what am I doing there? I am building a key file called Docker registry ingress. And then I ask it, hey, what is the service IP and what is the name of the service for which you want to generate a secret? Okay. And then I call OpenSSL and I ask it to generate me a certificate based on a key file. Okay. And then we take that certificate, and we copy it into the etc SSL cert. It is important that containerd knows about the cert as a cert. So when we generated this OpenSSL based certificate, it is a self-signed cert. Okay. This is a private IP VM, so typically Let's Encrypt will require a public IP to issue a certificate, and I was trying to go that route. I think the one where you can run an issuer, a certificate issuer, and all that kind of stuff. There is a way to use Let's Encrypt to do this, but the second way is what we're using over here, okay, which is ask OpenSSL to give you a certificate based on a key, and those things will have a subject which is set to the organization string. This subject over here needs to be the same as the IP address of your machine in our setup. Okay, because when CRI control goes to this ingress on port 443 and tries to initiate that TLS conversation, it's going to make sure that the certificate that is provided is indeed what is in the certificate, right? So it is talking to the right party. Now, if you don't do that, if you don't do this OpenSSL step, CRI control is not going to be able to fetch the certificate because it's not going to like it. What ends up happening is in vanilla Nginx ingress, remember, if I say this, right? So the Docker registry ingress is really based on Nginx ingress, right? The annotation inside of this ingress is Nginx based. And so if I don't supply a certificate, then it's going to, Nginx is going to turn around and issue a fake certificate, and you'll get like that certificate error. So in order to avoid that, I'm just creating a self-signed certificate that I then added to the etc SSL certs, and then I had to restart containerd, which essentially, I mean, I had to restart K3s. I don't know. I think there is some GitHub issue out there where they're talking about adding this feature in the future, where you can just drop in etc SSL cert, and containerd and CRI would be able to honor that as a trusted cert. But I had to restart K3s, which of course restarted the containerd as well. And once all of that was done, I was able to, do my deployment just fine, and I was able to fetch things. Okay, so now with all of this in place, we are going to sort of recap what we talked about so far. So the first thing is we need a certificate against the Docker registry ingress so that when Kubernetes asks the worker node, hey, let's go ahead and fetch this image and let's deploy it here on this worker node, okay? That's what we're trying to do. In order to do that, we need to make sure that this call is happening in a TLS secure fashion. Hence, we had to do some sort of a certificate. We had two options. We could have done a let's encrypt, or we could have done a self-signed. I'm doing a self-signed one. Maybe there is a way to use let's encrypt in this fashion in a private environment, but I don't know if that way. Maybe there is some sort of an offline CA you can do, but I don't know if that way to do it. So I just opted for a self-signed one. Now, there is one thing you have to keep in mind. You have to add the subject alternative name string and set it to the host name. If you don't do this step over here in this third line, if you see here, then your certificate still won't be honored, and you'll still get an error when you're trying to deploy and fetch the image. Okay, so that's what sort of is going on here. Now, you hit the Nginx, you hit the Docker registry ingress on port 443. That call goes to the service, Docker service. That Docker service sends the call to the Docker pod. Okay, and I'm going to actually just show you what that Docker pod looks like. Okay, so over here, I have a thing called Kubernetes Lens, which is an IDE that allows you to look at your pods and stuff. So it's kind of like a dashboard of sorts. And over here, you can see that I have lots and lots of these pods deployed, but we're going to go into this thing called Docker Registry pod. This is the pod that I have. And if I attach to this pod and I see what's actually running in the Docker Registry pod, I'm going to show you this. So if we go to, whoops, did it too early. Okay, so now if I go to cd, is it var log registry or something, or is it var lib registry? Nope. Where's the @c docker registry? Okay, and if I do an ls, oops, where's the registry here? Is it var log registry? No, not var log. What is the opt docker? Can't open that. Okay. Okay. So it's at cd. Well, let's go to this. So on the Docker pod, the registry is sitting at @c docker registry. And if I do an ls, whoops, that's not okay. Let me read the config.yaml to see what it is. Okay, it's sitting at var lib registry. Okay, so if I say ls var, let me scroll up a little bit. If I say ls, okay, can I make this bigger? No, yes, no, okay, whatever. Var lib registry, whoops, registry. Okay, ls docker. Huh? Wait, what? What am I going? Oh, var lib. No. Wait. Cat config. Where is it sitting at? Where is it sitting at? Var lib registry. Var lib registry. Okay, so this is cd var lib registry cd docker. Is it just symlinked or something? Oh, cd registry. Okay, cd v2. Okay, so now in the Docker pod, the registry is running on this address, var lib registry. Sorry, I was trying to make it bigger. So apparently you can do this. Can I make it bigger? Can I? Okay, no, I guess I cannot. Actually made it smaller. Okay, so that's funny. I can do this. So, huh. Anyway, the registry. So Docker registry is a pod. If you log into the pod and you go to var lib registry docker registry v2, you can see all the things that it is storing. Right, we're just and right there is our Flask hello that we. I think I haven't done this in front of you guys, but if you look at the slash uploads, okay, so that's cd slash layers. You can start to see the content of what you just pushed. Okay, so it's not gonna. I think it's just gonna be all SHA stuff. So yeah, so these are the layers and the of that Flask hello image. Okay, so when we go back to this over here and we push that stuff, that's what we're seeing. So what did we push when we did this thing? So we go to history and we say build. What did we build last time? Oops, sorry, grep. So we built a Flask 2.2. Trying to see, do I see a 2.2 here? Whoops. Okay, he's gonna say this is not found, but okay. Trying to see where is it Flask hello that has it? Where's our CD manifest, I guess? Trying to see where the versions are. Okay, so CD tags. Okay, you see that? You see 2.2 there in the blue. Look right there. That's is the image where we just actually let's just while we're here let's just go in and see. Okay, so this is the Docker registry. I don't know where I don't know. Is this something I should have done? Index. So if you see there, this is that image that was just pushed. Okay. I don't know. Is that readable file or what? Is that tarred version or what? Okay, so that's the image sitting on the Docker registry that we used Podman to build the image. Then we asked in our script, hey, Podman, push this to the Docker registry. And we had to do some search stuff to make sure that the Podman can talk to the Docker registry via its ingress. And once that was done, we logged into the registry pod and we went to the right registry folder and we could see our image and everything. Okay, this means we are ready to deploy this new version of 2.2. So now we're going to do that next. Okay, so if you see here, if I say, so now we come back to our project and we have a thing called flask.yaml. And I'm going to show this to you in a nice Windows thing so you can kind of see this. Okay, flask.yaml. Okay, it's just a deployment. It says, hey, can you please go ahead and deploy 333. Oops, I can't do this here. And replicas should be 3. And I'd like to, label it. This deployment includes all pods that have the app of label of Nginx, and trying to see like why is that Nginx? Let me have to see what this is doing in the end. Okay, so in the container section, we are telling it that hey, we would like to build, would like to pull this image, and then in the Flask hello. Trying to see, is there a how did we spell the Flask hello? Okay, with no spaces. Okay, and this time I'm going to ask it. This time I'm going to ask it to give me 2.2 version. Okay, I've already deployed a version before this, doing this video. So we're just going to come in here and say, hey, can you please give us 2.2? Okay, and well, actually, I also have to modify the already have this working in a deployment. So I'm just gonna say so 3333. Okay. Now if I say kc crictl flask.yaml, hey Kubernetes, please go ahead and create this deployment. It's going to go ahead and ask. It's going to ask the kubelet to ask the CRI compliant container D to initiate the deployment. The container D is going to pull the image. The image that the podman built is an OCI format, and that image is going to run. So several pieces here. Podman is what I'm using to build and push the image. Docker registry is what I'm using to store the image. And K3s is what I'm using to deploy and run the container image, my cluster, right? Underneath it, when I asked it to do the step, it asked the kubelet to say, hey, he wants this deployment thing created with 3 replicas. So the call went to CRI compliant container D, and it went and fetched that image, and you will see that image right there. See over here? Yeah, that's the image that it just pulled, 135 megs. Okay, so it was able to deploy that image. And if we see kc get pods, all of them, and then just grep into grep for flask. What do we call it? Well, let's just grep for 333. Okay, those pods are running. So now if we ask it to say, hey, give us the same thing, but also tell us what is the IP address of these. You see those IP addresses? Let me make it smaller so we can see them. Okay, those are the IP addresses over here. So now I have a command line browser called W3M. I'm going to take this W3M and I'm going to use it to show you what the thing does. Okay, so I'm going to have 10.42. We can run any IP pod, and the Flask app is running on port 8080. Okay, so when I hit it, ooh, it didn't work, huh? What is happening here? 42.0. Is it like this or what? Okay, unknown. There is a problem. Let's go see in our Kube lens. Is everything okay with our pod and our application? Okay, this is maybe a moment of learning. Stuff does go wrong. So you see all these pods were just deployed 2 minutes ago. Okay, and I'm going to just randomly pick one of these pods, and I'm going to ask it to, well, let's look at the logs real quick. So the logs are command line Apache D cannot reliably determine the service fully qualified domain name using this. Okay, fine. Okay, why is it running Apache? Is it supposed to run Apache? Is it based on Apache? Let's see. Or am I mixing two things here? Maybe I'm mixing something here. Cat. Okay. So take Python 3 and cat requirements. This says Flask. So why is there Apache? Did I take it and somehow run the wrong image? What is Apache coming into the picture? Let's look at the other one. Let's see what's going on here. Okay, container D asked us to do something. Looks like. Why hasn't it come up here and told me that there is a thing running on port 8080? That's what it did last time. It worked on my machine. Okay. Is it running? Let me see. Let me see what. Let's attach to the pod. Okay. Let's go log into the pod, so to speak. Let's see what is running here. PS. Whoops. Too quick. PSOX. Apache is running. I don't see any Python Flask or Unicorn type of stuff running. Okay. What is going on? Why is it picking up this thing? If I say curl HTTP localhost 8080, is anybody listening? Nope, nobody's listening on port 8080. That means I didn't deploy the right image. Now we have to debug what is going on here. Okay. So when I built the image, I built it using this script called build.sh. Okay. That's the base image, all of that. Okay, Podman, please build this image using Dockerfile here, which is in the right directory. Okay. And t-image, tag it with the image, and then push it. Okay. Let me run it one more time. I'm going to say this is called Flask app, and the version is 1.0. Let's do that. Okay. Okay. So now if I say sudo podman images, I see Flask app 1.0 right over there. But the image is 45 minutes ago. It's using an older layer. I'm trying to see why. Why is it using a cached layer or something? Because the image ID is exactly the same, isn't it? You know what I'm going to do? I think that I probably picked up the wrong Docker file from here. And this has PHP Apache. And it needs to like upgrade into something else. So what I'm going to do is I'm going to just touch something in the app. I'm going to go in here. And I'm going to see, I don't know, just create like a ls touch, let's say app page 1.html. Okay. That way, you know, it thinks that, hey, there's a new app here. There's a new version. I don't know. Maybe it needs to redo the thing. Okay. So now I'm going to ask it to redo the build one more time. Okay. And I'm trying to see if this will come on. Should I just do a recursive search? Let's see. Okay, so this is happening, looks like. And it's rerunning the requirements.txt. Okay, looks like it detected a change to the project. Looks like it's doing its thing. It's uploading. Looks like that's all uploaded now. Let me see if the if I say sudo podman images. By the way, podman images and sudo podman images store images on two different locations. So you have to be mindful of that. So let's see. Looks like now we have a Flask app with 1.0 and the image is different. Look at the image ID. It looks like a different image and it looks like it was built 15 seconds ago. So now what I'm going to do is I'm going to try to deploy that one. Okay. So we need to just go to vim the Flask app. Oh, why? Oh, there's no YAML here. Vim flask.yaml. If I go in here, let's just for now just say for and over here let's just say flask. Whoops. Let's say flask app, and then let's ask it to give us 1.0. Is that what we built, by the way? What do you mean? Okay. Cat flask.yaml. Looks like it. And then sudo podman images, and then grep flask. Flask app 1.0 is there. Flask app 1.0 is there. Notice that if I do CRI CTL images right now, nobody has asked it to go and fetch. So this should not be there. Notice that? See that? Over here, the last one is still sitting at 2.2 and it's still called Flask Hello. When I go ahead and ask it to deploy using KC creatf flask.yaml, now it will go ahead and try to create that deployment with 444 of tag name, of course. And once that does happen, you will see that the right image is deployed. Hopefully, fingers crossed. Okay, what happened to them? What happened? Successfully pulled image Flask app 1.0. Show the logs. See if it's running something on port 8080 or not. Nothing in the logs, huh? Is it still coming up? What's going on? Let's close the other ones in the meanwhile. Somehow it picked the wrong image, I think, last time. So let's see. Let's look at the logs. Nothing in the log, huh? Maybe if we we ask it to say, hey, tell us, give us the IP addresses again. What? I mean, like, ask it to give us the pods, man. Let's see the IP address again on the 444. Okay, so if we say W3M HTTP 10.42.0.71:8080 contacted. The host name of this container is, and its IP is this. Okay, that's what we were wanting to see. The app is up and running. It's got the right Python Flask app deployed on it, and when we hit the home page, we see this. We see this is our home page, and I can actually just show it to you in a regular browser too. Coming up. Oh, I forget. It's a private IP address. It's not gonna go across the wire. Okay, so you can just see it. I don't have a service exposed here, but if you see the curl, you say the it's not a curl, it's like a command line browser. The host name of the container is this host name, and its IP address is this. This is coming from our Flask app, and that shows you what we did. So just to recap, the first thing we did is we installed Podman, and we asked Podman to build the image for us. We got the a project called Python Flask app from GitHub, and I provided you guys the URL for that. You can clone that repository, and you can build the image. And once the image is built using Podman, you push the image, and that's all is in that build script. It not only builds the image, it also pushes the image. Once the image is pushed, you go into your deployment, and then you update the Flask YAML with the right version number, and the thing runs. Okay, So now what we're going to do next time is we're going to take this Flask app and we're going to deploy it with a new endpoint called CPU load/CPU load, which is going to stress the CPU of the pod. And then we're going to get back to our main topic of autoscaling. We're going to see autoscaling working in action. Until next time, thank you.